3, a picture, and we are going to draw a reference triangle. And what do I know? That this length is 4, this is 3, and what is the hypotenuse? 5, which leads me to Pythagorean triples. That is the most famous Pythagorean triple. Why is it a good thing to know some Pythagorean triples? Because it just makes things speedy. You don't have to actually use Pythagorean theorem to find that third side. Can anybody give me another Pythagorean triple? Yeah. 8, 10, I wouldn't put it in that order. 6, 8, 10. Any multiple of 3, 4, 5 will work for sure. Okay. Besides multiples of 3, 4, 5. 9, 24, 25. Check it out. Use your calculator. 25 squared minus 24 squared. Oh, sorry, that's 7, 24, 25. It's 9, 40, 41. 9, 40, 41. Let's check it out. 41 squared minus 40 squared. Yeah. From Pythagorean theorem. These are Pythagorean triples. Mean when you actually plug them into a squared plus b squared equals c squared, they're whole numbers. There's another one. 8, 15, 17 is another one. Another one is 5, 12, 13. That's another famous one. And do you need to memorize them? No, but will it make your life faster and easier? Yes. So okay, so why are we using them? 3, 4, 5. Otherwise, I have to go 3 squared plus 4 squared equals hypotenuse squared and solve it. It saves time. Okay, so what is sine theta equal to? Reading my triangle here. It would be what? Opposite over hypotenuse, 3 over 5. Cos theta, what's cos theta equal to? 4 over 5. Are these all positive? Why? It's in quadrant 1. What's also nice about quadrant 1 is the reference angle is the related angle. Tan theta. 3 over 4. Yes? Okay, now we need to solve for theta. All of these are actually the reference angle. Okay? So how would I actually get the reference angle here? $36.9? Anybody else get that? How do I get that? Choose one. Inverse it. There you go. Okay. Inverse trig. That means my answer is therefore 36.9 degrees. And you're saying, what? That's because it's the same. Theta and theta are the same. But if I go to this one here, let's just do a quick sketch. If I go 5 to the left and 6 up, I have a nice little triangle here. And how do I get that hypotenuse? It's not one of my Pythagorean triples, darn it. So 25 plus 36 is 61, so it's a root of 61. We always use exact values. We never round unless it's the last thing. So what is my sine theta equal to here? What's sine theta equal to here? 6 over root 61. Is it positive or negative in that quadrant? Positive. Cos theta, what is it equal to? Yeah. Moving on. What's cos theta equal to? Negative 5 over root 61. What's tan theta equal to? Is it just 6 over 5? No, it's negative 6 over 5. So hopefully you learned last year that you don't, when you try to solve for theta r, remember this is theta r, that you don't use the sign, meaning plus or minus. You just use the positive value of it. So what we're doing is we're finding the ratio in the first quadrant, and we're going to generate the angle in the second quadrant. Okay, so let's find this one. What do we get here? 50.2. If you do inverse cos of 5 over root 61, you'll get 50.2. If you do inverse tan of 6 over 5, you'll get 50.2. If you use the negative, you will not get 50.2. It'll put you in a different quadrant. So that is not my answer, though. I need to find what that is. Yes, 180 minus that. So what do I get? So that would be my final answer in that case. Okay?